right. Hey, everyone. Thanks for dropping by the stream today. Uh, we'll take a second to introduce ourselves. But the main topic for this stream, I believe, is going to be to talk a lot about, what is game programming, what exactly is the differences between programming and game programming, and maybe kind of shed a little bit of light on what that experience is like working as a game programmer, if that's something you're a little unsure about. I also want to make sure we get a chance to talk about what we do at AIE here, as far as teaching you how to become a game programmer is like, and what the day-to-day student experience is going to be if you choose to attend. But before we get into all of that, I should introduce myself. So I'm Terry Nguyen. I'm one of the 2 game programming instructors here at AIE Seattle. My background is in a variety of different things, ranging from working in mobile games to building things like casual apps for managing your stress and anxiety, to working on action adventure games, platformer games for PC and desktop as well. So that's the sort of general bulk of my experience is just working in a lot of different types of games, I suppose. But I'm really, really interested in programming all the time. It's what I do, maybe for fun as well as for work in what I do here as a teacher. And I'd probably say that it's a really rewarding experience. But if you've got any questions about that, always feel free to pop it in the chat. But I think I'll pass it over to Danny.
Hi everyone, my name is Danny. I'm an event officer here at the Academy of Interactive Entertainment. I go to events and to different schools to go with the students who are interested in our programs. So yeah, I'm very happy to be here and excited to talk about game programming.
Hi everyone, my name is Pardis. I'm also an events officer. I do the same thing as Danny. I go connect with students at other schools and let them know about the programs that we offer at AIE.
Sweet. So just in case anyone missed it, the stream is going to run for about 30 minutes. I won't try to take up all the time with all of the stuff we've got to talk about today, so feel free to just toss in your questions as you get them, or we'll make sure to try to save a little bit of time towards the end to field some of those questions. But unless you've got questions for me, either Danny or Pidis, I think we can probably talk about just what programming is. Cool. So what you're taking a look at here at the moment is some of the student work that was done last year for the major production project. That's the end of year capstone project that students work on. And in this one in particular is actually the year 1 project for this current cohort here. The project you're looking at is Fright Night. It's a 3rd-person shooter created using Unreal Engine. And the idea is that they want you to go through and take on the role of John Fry, a lone Fry that has been left behind overnight. And his goal is to go through and try to make his way out of the little fast food joint that he's been stuck in. And just to tell you a little bit about some of the work that students had to do to put it all together, is a team project, right? So this isn't just something that every individual game programmer does. They actually team up with the designers and artists because that's what games is, right? Games is a multi-discipline project. You need artists, designers, programmers, sound people, music people, but even marketing and business people and lawyers to really kind of get it all together. Now, the student projects don't quite work on that grand of a scale. In particular, the game programming department here collaborated with the game art and animation course, as well as the game design and production course to build out this project. But taking a look at some of the screenshots they've got over here, the goal was to kind of build out a, not exactly a one-to-one replica of a fast food place, but to try to create a little re-envisioning of what it would look like in a more cartoony type world, and from the perspective of something as small as a fry without being overwhelmingly large and too difficult to explore. So the team had to make a lot of creative liberties here, such as piling up a bunch of boxes in a semi-unrealistic fashion, but in a somewhat interesting and different arrangement. And if I pop over to the actual gameplay of it, what you can kind of see is John Fry. So I'm not going to play through the whole thing. If you are interested, you can always find it by talking to our admissions reps or checking at our website to see if you can grab the download for it. But it's all created with Unreal, and the goal is to just kind of make my way through the level here. So a lot of the work that had to go into it was just blocking out this level, trying to think from a moment-to-moment basis, what is the player going to be seeing as they go through the level, and what should they be thinking about. So I know one thing in particular that was difficult for the team was that when they were going through and building out this first section, they really had a tough time trying to tell the player how to navigate from where they're currently standing here up to that little section over there. And one of the things that they ultimately settled on was creating this little line of enemies that they need to defeat. Oh, I missed the jump. And make their way up through there, while also trying to avoid all of the moldy cheese. Oh no, that is chasing me. But that's the general idea of it, right? And to that extent, they were able to take about 8 to 10 weeks or so to do this. And we encourage all of them to constantly be playtesting the game and trying to see how players respond to those changes, right? So what you see here is just the final result of a lot of the work that they had to do to go through and actually create a cohesive experience. There are definitely lots of variations of this level where they had different routes that going in different directions, lots of different signs to try to point the player where to go. But ultimately, players don't tend to read a whole lot of the time. Or if they do read, it's a small fraction of them that do. So we really try to make sure that you don't have to think too hard to go through the game. You just mostly need to just try to go with your gut instinct as much as possible. But I don't want to dwell too much time on their first project. Their new project, although with not exactly the same team, is this new project called Terratots, Lost in Underspace. And what you've got kind of on screen here is their pitch deck that they had assembled to try to create a quick explanation of what the game is going to be. So in a nutshell, you are effectively playing as this Delver character that's going to be walking around in this underground zone, and you've got to recruit these little Terratots to try to navigate that dangerous space below. And what I wanted to focus on with this is they presented a lot of mechanics. And one mechanic in particular that I should jump to, let me see here. Yes, is they wanted to illustrate that in the game loop, there's going to be a exploration section, a storm section, and then a post-storm phase. And since this is a stream about game programming, it would be unfortunate if we didn't talk about programming. So when it comes to the nuts and bolts at the end of the day, here's what the programmer has to ultimately do. Now, this project is in Unity, so we're looking at C#, not in C++, but the same basic principles still stand, right? Our goal is to go in and take these concepts, these features, and translate them into text. So this is a big storm mono behavior, and the idea is that we can attach this to objects in the level to give them some logic that is specific to the game. Now, the big storm is supposed to be a big critical event that happens where it actually damages everything on the level, and you're supposed to try to avoid that as much as possible. In order to make that happen, programmers have to write code to do that. So when you or a designer describe the actual feature that you're supposed to have, the programmer goes in and writes that code. So in this case here, we've got a little snippet from this update method that is implemented as a part of this big storm class. And just to kind of walk you through it in a quick nutshell view, basically what we're saying is, hey, if the storm is not currently running, then we're going to go through and update the amount of time that's left until the next storm runs. We want to make sure that the player actually can see this and understand what's happening. So we want to update the UI to actually show that this is the case. Once that's the case, if we know that we've run out of time and it's now time for the storm to appear, we start the coroutine here for summon storm, and that actually brings in all the particle effects that show that the storm is happening. We start applying damage to all the enemies that have not taken, or all of our Terratots that have not taken shelter. And then we want to make sure that we want to start the timer so that the storm eventually ends. So that's just kind of a quick overview of what a programmer does. So if we want to pop back over to my colleagues here, Pardis, and maybe we can talk a little bit about what exactly goes into game programming at AIE.
Yeah, so you'll learn like a lot of skills like Terry mentioned. So things like C++, C Sharp, OpenGL, other game engines. And you'll do like a minor and major project, minor project with the first year, major project with the second year. Do you want to add anything else, Danny?
Yeah, we're also utilizing Unreal Engine at the school as well. And again, like Priest is a 2-year program. So first year's your minor year, second year's your major production. What's pretty great again is that your second year is kind of also dedicated into like helping your network and helping you kind of find these other skills that are utilized in order, to find positions or anything after you graduate here at AIE as well.
For sure, for sure. Yeah. So I think maybe one thing to touch on then is we've talked a lot about game programming, and I think we've highlighted a lot of the work that goes into games. But maybe one thing we should probably clarify is, what exactly is the difference between programming and game programming? And the favorite way for me to explain this is that when it comes to programming, right, that's just a big umbrella of all the ways you can solve problems using code, right? I often describe myself as kind of a lazy person. I really like using automation to do things for me that are tedious. Like, for example, I've got a Steam Deck next to me here, and one of the things I've done recently is I wrote a little bit of code to help copy all of my game saves off of the Steam Deck and onto my computer so I can continue playing there. And once it's done, I can have that automatically transfer stuff back over to the Steam Deck. I could do that all by hand, but I'm a programmer, right? So I'm just going to program myself a little solution to do that for me because I'm a little lazy. But I don't mind spending a lot of effort up front so that it can be done automatically later on. And that's kind of the heart of what we do as programmers. And in particular, in games, there's lots of different types of programming that can be done. One of my favorite questions to ask when I'm talking to either a student or someone who's just interested in programming is I'll ask them, what kind of game programming do you want to do? And usually the answer I get is, I'm not sure, Terry. There's multiple kinds of game programming. And I'll say, yeah, right? Because there's things like gameplay programming, where you actually build out the mechanics, like the storm I was just talking about. But there's also tools programming, right? That same programmer that built that has also gone through the effort of building little in-editor knobs and buttons and numbers that can be adjusted by designers to tweak how that storm works, right? One of the big questions that that team is trying to grapple right now is, how long should the storm be and how much damage should it do over time? And that's a really important question, right? When they started out, they only had it working for about 10 seconds. And then in that 10 seconds, if you didn't immediately take cover, your character would lose all their health and you'd have to restart back at camp. And what we found is that that's kind of a weird and confusing experience for players. Why does the storm just appear ever so briefly? Why is it just flashing by and then it's gone? Shouldn't it take longer? Shouldn't you have more of an opportunity to take cover? And so, building the tools that make it possible for the design team to adjust that on their own is a really important part of that process. Another thing that's really important is building out the backend services. So although this game is single player, it doesn't need a whole lot of it. If you've ever played a online game, you probably have to log into some server. You probably have to grab your inventory data. You probably have to start playing in a world with other players. And it takes a lot of code to synchronize that across machines, right? When I'm playing on my machine and possibly like playing with Danny in some kind of like online shooter, there's a lot of work that goes into making that happen. And so that's another type of work that can be done in programming. The other thing that's also really key is with all of these roles, right, whether it's gameplay, tools, or servers, the other thing that's really key is that it has to be performant, right? And that's the other thing I touch on, is that with some types of projects, it's acceptable for it to take maybe a second or 2 or 3 for the work to be completed, right? But in games, when I press W on the keyboard, when I push forward on the joystick, I expect my character to start moving immediately. And that means that we have to write fast and efficient code to make that possible. Cool. Any questions on that, y'all, before I jump into my next topic? Seems good. Okay, cool. So now that you know the differences between programming and game programming, where does AIE play a role in that? Well, I say it always depends a little bit on the instructor, but Rob and I, Rob being the other game programming instructor at AIE Seattle, generally have a pretty strong focus on making sure that you're actually doing the work, right? So when you're in the classroom, we really want to focus on showing you new types of techniques, new types of tools, and ways to solve problems, and actually giving you the opportunity to do that when you're here, right? So oftentimes we either have a project that we ask you to work on, or we have a series of exercises. Say, for example, if in the AI subject, we've just talked about using behavior trees to create a AI agent that is capable of patrolling to different points in the world, and then detecting if the player is nearby and then chasing after them. We're going to have you actually do that, right? We want you to actually put that into practice and see how easy or hard could it be. And we fully expect that you're going to struggle a little bit along the way, right? If you could just instantly be told how to do something and then do it perfectly without any struggles or issues, then you probably don't need a course like this to help you. But what we do want to make sure that you get is you get the experience of collaborating and getting help from not only your peers, but also the people that are helping you manage your work, right? Your technical directors and um, your leads. So part of that is giving you practical problems to try that on. So a common problem that students often run into with that type of work is they'll ask me something like, "Hey Terry, I'm not sure how to take this feature and translate that into code," right? And my goal will be to not give you the answer, but work with you to find a answer that works for your current program. Because here's the thing, right? We will talk about these things like behavior trees, decision trees, finite state machines, et cetera, but how you apply them to every single project kind of differs, right? Because the constraints and the needs of each and every single project will differ. So my goal is to try to work with you to help you understand how you can actually adapt the thing we've just talked about and actually make it work within the confines and requirements of your project as well. So that's another thing that I think is really important to us. So important, in fact, that I generally don't like lecturing for too long. I'm not sure about other instructors, but my general goal is to try to hit about, say, no more than about half an hour to an hour of like lecture for in the morning, and then we'll try to spend about 3 hours just actually giving you the opportunity to do the work and struggle through it, and then we'll review some of that work towards the end. And then the afternoon is going to be the same deal. Once you're back from lunch and hopefully feeling a little bit more refreshed, we'll talk about a new technique, a new problem to solve, and then we'll give you, again, the time and space to solve it. Cool. Sounds good. Sounds good. Nice, nice. No questions in the chat so far, but again, if you've got questions, please do pop them down. Would be happy to answer them. Another thing I think that's important to highlight is just the collaborative environment that we try to encourage you all to have. You might have noticed it earlier, but I did mention that we want you to actually talk to other people like a programmer, right? And that includes talking to your peers. It's not the type of class where you just jump in and you kind of sit silently and maybe look at me for 5 to 6 hours a day. It's really about looking at the code, and then when you run into a problem, when you struggle a little bit, you can turn to your partner and say, "Hey, I'm not really sure why this is not working. Can you maybe take a look? Can you maybe tell me where I'm going wrong?" And I'll do this all the time. I'll even turn to Rob and say like, "Hey, Rob, am I doing this wrong? Is there like a different API I should be calling?" So that's a really important thing that we want you to feel comfortable doing. Looks like one question we do have is about the software we use. So this does change from year to year, but recently what we've been moving towards is working with C++ and Unreal being sort of the main targets that we're going to be learning. And in that is going to be a lot of other pieces of software that we're going to use along the way. The premier one is going to be Visual Studio. It's basically our IDE of choice when it comes to Windows development, and it's very well supported by a lot of the major engines that are out there, whether it's Unity, Unreal, or otherwise. So we'll get you a lot of time working and writing code all day long. And by writing code all day long, I mean writing code and feeling a little frustrated as to why it just doesn't work. But that's okay, because tools like Visual Studio have debugging tools built in to help you understand why this bug is happening, right? You can use things like breakpoints to pause at a particular section of code and just see all the data and take a look at what's happening. Or you can use things like log statements to print out information along the way, and you can watch in real time as the game is running what it's trying to do based on the print statements you're seeing. So those are the key things that we do.
So we have a question about what type of positions in the game industry do graduates get hired for?
Yeah. So, as far as positions go, it really depends on the student a little bit and where they want to go as far as the general geographical area they want to be in. Obviously, if a student is looking to stay in Seattle, that does limit their options a little bit. But there are a lot of game studios in the area. Predominantly, what we see is that with our students, we see a mixture of not just employment in games, but also in other sectors that may make use of the tools that we use, like in Unity and Unreal. So, for example, I think we've had grads go off and try to build mobile games and build games that integrate with that type of technology. We've had students go out and build simulation and training tools for other companies. So, not necessarily games per se, but they do use game engines to facilitate that same type of experience. One area that we've also been seeing a lot of interest in is VR simulation and training. So again, not exactly a game per se, but if you're training someone to use a particular piece of equipment, VR can be a tool to help you do that.
And we also have another question about studios that graduates have been hired at and also other companies that hire graduates.
Yeah, I think, let's see here. I don't have a list right next to me, but going off the top of my head, I know we've had a number of graduates over at Hashbang Games. They tend to do a lot of subcontracting out to other firms. We've had students go out and work at places like Bungie as well, doing things like technical artist type of work. So instead of just being purely art and purely code, you really try to use both code and art to create interesting and interactive effects as well. It's kind of a nebulous term that really kind of depends on a per studio basis. That's the general idea behind tech art. Yeah. And then let's see. Let me pull through my notes here. While I'm going through my notes, are there any other questions to roll through?
Yeah, Terry, can you do you have any advice for someone starting out, just like learning about game programming?
Cool. Let me make sure I come back to that question on studios. But as far as advice for someone starting out in game programming, realistically, I think the key thing is just to start writing code. Yeah, is just to start writing code and try to write code that involves you doing the problem solving. One struggle I see with a lot of graduates that apply, or not graduates from AIE, but graduates from like high schools and whatnot, is that they've done a lot of training in like a skill center. And this isn't the case for every single skill center, but some of them have only been copying along what their teacher has been giving them for code. But when I ask them to go out on a limb and say, how would I program something that gives me an extra 5 seconds when I pick up this coin, or how do I program something that gives me a speed boost when I pick up this little object, they might get a little stuck. And the most important thing you can do is just try to solve your own types of problems and try to take your best guess at it. What you'll find in programming is that you often don't know the best way to solve something until you've already done it. So rather than get tied up on the best way to do something, just write code. Just build things that you think are interesting, and it always helps, right? You might be thinking, "Man, I didn't really figure that out." That's kind of a waste of time. It's not. It's not a waste of time at all. It's actually really important that you do that because the problems that you encounter are actually generally applicable in other things. I would even go as far as to say that my time in Unreal has made me a better Unity programmer. And my time in Godot has made me a better programmer in both Unity and Unreal, right? Each of these different engines and tools have their own strengths and weaknesses that can be carried across to other tools. Looks like we've also got a question in chat there. Sorry to steal your job. Yeah, we got a question for how old were you guys when you started game programming? For me personally, that's kind of a nebulous question, but I would say I technically started programming when I was 7, but I was only writing HTML code, and that means basically just web pages, right? It's not really the same type of work that I do now in games, where we actually write systems. And I would say I didn't necessarily start writing systems until I was about 17, 18-ish, and that's when I started picking up C# and C++. I don't know if either of you have any programming experience of your own.
I do not have programming experience. I connect with students about what AIE is.
Same with me. I work the same as parties. The only kind of coding I've had was when, again, as a kid, I would do some like HTML website stuff. I know a little bit of that, but not really in gaming.
Gotcha. I mean, it's never too late to start. You can always start.
So true. So true. Very useful skill.
Mm-hmm.
Yep. Jump back into the question about other places that grads have been hired. Aside from doing a lot of contract work elsewhere, I know one studio that had hired a lot of grads a while back as well is Hardsuit Labs. Again, they similar to Hashbang. Though they both start with an H, there's no real relation. They also do a lot of subcontracting work to other studios and teams. So although they don't have any titles specifically to their name that they have released, you'll find that in this industry, there's a lot of studios that do a lot of work for each other. And so they often get listed in the credits for those types of things, but are maybe not the sort of main logo that gets splashed onto your screen at the start of the game.
And then we have something else in the chat as well. It says, I hear a lot about C# and C++ for game programming. What is the difference and what could I start with?
Yeah, so C# is less. Funny enough, this also starts with a C in both cases, but no real relation there. Superficially, when you look at a chunk of C# code and you look at a chunk of C++ code, they kind of look a little similar. They start with the whole int main kind of deal, and you can print hello world kind of similarly in both those two cases. But under the hood, they actually work a lot differently. Without getting too deep into the weeds on the details, C# is a little bit more high level. It runs on what we call a virtual machine, and then we write code that becomes bytecode, and then the virtual machine, sort of the machine inside your machine, runs that code. Whereas C++ is more generally regarded as like the low-level engine, or sorry, the low-level language, because that actually runs more or less on your processor, so to speak. It compiles out the machine code, and then it runs directly. There are some advantages and disadvantages to learning either one. Although in the AI Seattle, we're planning on covering C++ first thing next year. It really doesn't matter which one you start with. You really just need to pick a language and start writing code, because the general concepts apply, right? You make variables in C#, you make variables in C++, you make functions in C++, you make functions in C#. There are differences behind the scenes in the way they work, but the general idea translates, right? And I do this for myself as well. I would say that I generally program in C++, C#, now also Godot script and maybe Unreal Blueprints. But I also spend some time in other languages as well, like Rust, TypeScript, JavaScript, Python. Though I don't feel like I'm a master of those languages, but I know enough about C# and C++. I know enough about those two languages to understand the general idea of I want to make a variable and I want to put data in that variable and change it in some way. That general idea generally applies to most programming languages you're going to encounter today. Starting at 7 is pretty young. I suppose so. But I would say like I wasn't programming actively full time as an 8-year-old or 9-year-old during the whole process. I picked it up a little bit, and then I just knew that it was a recurring interest that I wanted to do, and I just kind of kept trying it again and again and again. Like I had tried HTML, CSS, JavaScript, Python. I never really felt like I understood what I was doing with code until I picked up not C# surprisingly, but C++. C++ is really the first one that, to me, I felt like I knew what I was doing, which I think would be a surprise to a lot of people, because a lot of people feel like C++ is a scary and daunting language. But I would say the reason why it is a little scary and daunting is that it gives you so many tools. It gives you 20 ways to do one thing. And ideally, like the one thing that I think is important when you're teaching someone C++ is to not show them the 20 different ways to do that one thing, but to show them like 1 or 2 good ways to do it. And then you can start to kind of broaden out a little bit. Cool. So I know we are running a little short in time. In fact, we're a little over, but I figured maybe we can talk a little bit about the game programming course and the advanced diploma that we're currently offering. Do you two want to kick that off?
Yeah. So again, it is a 2-year course, a 2-year program. It also can be done fully online as well. But again, our campus is here in Seattle and next to Space Needle at the Seattle Center. We're on the top fourth floor of the Armory building. Um, and yeah, it is an advanced diploma with after your 2 years. But again, we kind of offer ways to network and ways to kind of find any sort of internships or roles within a year after you graduate. Um, and we also, again, if you're interested in coming over and doing some visits or a tour, we our campus is always open, but every month we also have an open house or an I-Day. They kind of interchange every other month. This month we have our interactive experience day or I-Day, which you can come in, talk to the professors. They will kind of give you a kind of a crash course of like programming, animation, and kind of go through the simple kind of foundations of it and see how you kind of are liking it, and obviously ask any questions as well.
Cool.
And then
Sounds
we
good.
have something in the chat as well. It says, "What was the first game you ever made?"
Ooh, first game I ever made. Um, let's see. I'll make that a quick question. First game I ever technically made was a game called Defend the Taco Shack. It's a side-scrolling shoot 'em up game where you play as a little guy with tacos, and you need to feed everybody that is coming at you in a horde of hungry people. You need to feed everybody the tacos, or else they're gonna raid you for all your tacos. But my first like commercial game, I would say, is probably Sinus Sprite. I worked on a game where you can play little mini games to try to gather some information about how you're doing as far as your stress levels and anxiety levels go. And that was for Android and iOS. But yeah, we can probably pop over to the website real quick here to take a look at the game programming page. So what you can kind of see here is if you visit our website at aie.edu, under the sidebar here, you can check out game programming. So I believe the next intake that we've got a opening for game programming is going to be in the fall for this year. And that's going to run for a total of 4 semesters. The fee schedule is also available here as well. And then since I'm just the lowly instructor here, maybe I can pass it over to our admissions team to talk a little bit more about what people should know when they start thinking about this. Might be a little occupied, but I'll just pick up here and say you can check out all the stuff that we just talked about as far as like software that you can expect to pick up. I did mention Unreal and Visual Studio and C++ being the key ones, but there are a whole host of other tools that we use as well, like the Perforce server that I sort of administer locally here, as well as Git that we use for some of the smaller, more personal projects, and then a number of libraries that we pull in to help solve various types of problems like sound and keyboard input and whatnot. If you are interested in applying, I would recommend hitting the big Apply Now button on the right or the big Apply Now button on the left. And what that'll do is just pop you over to the little form, and you can follow that all online from your web browser.
The application is completely free, and again, we are portfolio-based kind of application, so we don't look at GPA scores or ACT scores. And again, completely free. So if you want to come try it out, feel free to hit that button. And again, if you want more help on the application process itself or talk to an admissions officer, our IE day is this. It's on May 18th, so not this Saturday, but the next one. And again, feel free to come in. It's a lot of fun. You get to work on some games, talk to the teachers, and talk to our admissions officers as well. If you want to go on our website, it is under Showcase and then Events. On our Events tab, you'll have the iDay registration form. Feel free to sign up on there if you want to. Again, we have an iDay and open house interchangeably every month. So next month will be an open house, and the month after that will be another interactive experience day.
Gotcha. Sounds good. One thing I should probably note as a part of this process is when you apply, part of what we'll be doing is having you go through and complete a interview during which you'll have to provide a small portfolio. One thing I should probably clarify is that the portfolio doesn't have to be a super scary process. It says here generally that we want to see that you've done some level of programming, right? You can bring us any like sample projects that you've done, any like projects that you picked up on a weekend or so, just to kind of show us what you've done and why you are interested in game programming. That's really what we want to know. We don't need you to be a super skillful programmer when you're coming in. That's our job, right? We want to make sure that you know what you're getting yourself into when you apply is the main thing we're looking for. Looks like we've got one more question in the chat there. Is this fun for you guys? Yeah, I would say I really enjoy programming. That's pretty much what I'm doing most of the time. If I'm not sleeping, if I'm not gaming, then I'm probably programming. Well, hopefully I'm doing some teaching somewhere in that process. But yeah, no, I really love programming. It's probably one of my favorite things to do. I write code for fun. I write code for work. And actually, I should probably note that writing code for fun is actually really important if you do choose to turn your hobby into a job. You're not always going to be writing fun things. You can find ways to make it fun, but if you want to keep that spark, that joy of programming for yourself, you should probably also find the time to sink a little bit of time into a side project every once in a while. I think it's a really healthy thing, and it's really something that I encourage graduates to do when they leave the programming. When they leave the program, is that some of them tell me like, "Hey Terry, programming isn't what I thought it would be," and I'll ask them like, "What have you programmed for fun?" And usually the answer they'll tell me is no, nothing. And so that creates a really good opportunity to just kind of reestablish that healthy, fun relationship that they had with programming. But cool. If that's all the questions, then let's see. We're just a little past the 30-minute mark, but I really appreciate everybody making the time to either present with me today. Thanks, Danny. Thanks, parties. And also everyone in the chat for just asking questions and giving us some stuff to talk about.
Yeah, awesome.
Yeah,
thank you, everyone.
Terry, and thanks for everyone that came to this live stream.
Yeah, it was great. Again, May 18th, we have an IA Day. Please come over, look at our events page on our website at aie.edu. And it'll have all of our upcoming events stuff. So please feel free to register, and we'll see you on May 18th.
All right, take care, everybody.
Bye.